So when you're grad students together, there are stories. So my work as a historian is a little weird. I'm a historian of biology. I have my degree in ecology and evolutionary biology. And now I'm doing the oldest history there is, evolutionary biology, but also doing the history of people. And as I think I told our class, I really think I'm just still doing ecological principles and evolutionary kind of reasoning, because I'm dealing with people, how they come up with ideas, but it's always about context, contingency, change, dynamics. It's a system interaction, and which is much of what ecology is and much of how ecology feeds into evolutionary biology. So my work is focused on methods and reasoning, how scientists make discoveries, how they persuade others that they should believe these discoveries, sometimes controversy. Historians particularly focus in on controversies like over mimicry, but then mimicry became the thing that's in every Bio 101 textbook. So this was these kinds of perfect case studies for us to what really draw us in. So I'm really interested in the ways of thinking and then how they get applied in the field, which is what brought me into teaching field animal behavior. A fish ecologist and a neurobiology behavior faculty member thought, would it be great to have these principles brought in so you learn how to do field work in part with the historical examples which are represented on this island, actually. So I'm kind of naturally drawn to the intriguing figures of people like Darwin and Wallace. They were transformational in the work they did, and they're models of scientific field work and the theorizing from field study. But the other thing they are is they were very young when they did this. Darwin set off when he was 22, having had no biology classes. He hung around with the botany professor and he spent 2 weeks with a geology professor learning field techniques. And he had a lot more, as we'll see. Alfred Russel Wallace was a self-educated man, and they did this fundamental work. So that's kind of nice. But that's the formal version, why they're interesting. I'm a historian. What I really like is reading dead people's mail. So that's our source material, is their journals, their field notes, their mail. And for me, also experiencing the places they went to make it more physical than maybe many of my history colleagues might do, to know that they had to be immersed in some environment. But they are a great example. You can read the words faster than I will. So this way I get twice as many words in. I say mine, you read those, and I get double there, Hal. So you can see what I think is really important is that they were constantly observing, and they were the kind of observers who were constantly asking questions in the back of their head, not just listing things. They were both collectors and had to do the taxonomy, but it wasn't enough just to put the name on. They liked seeing what the animal was doing, right? And they also were seeking explanatory principles, as we'll see, and ended up inventing testable theories, and even more important, realizing that the theory they came up with kept extending to more and more biological phenomena. The first phenomena of application for evolutionary theory was camouflage and mimicry. Guess why I studied it? Okay, well, actually, I can walk around a little bit. The map is, there. It's a little misleading. This is what you always see in the books. The Voyage of the Beagle as the book. He called it the Journal of Researches on HMS Beagle. A far more honest title than the popular press title now, because that voyage, it's all in the ocean. Well, he spent 4.5 years on this expedition. He spent maybe 6 months at sea. He got seasick. He hated it. It was cramped, couldn't work. Every chance he got, he went ashore. The obsessive captain went back and forth up and down the coast doing the surveying, what the ship was commissioned to do. So Darwin really had the walk across South America. Right. So there's another way. There's something a little misleading. I'm talking about islands tonight, and you all immediately thought Galapagos, the least important island on his voyage when he was there. One of the most important islands when he got home and started thinking about it. But the problem is he wouldn't have even noticed the stuff in the Galapagos if he hadn't paid attention to all those other islands. So they play really large in the way he thought. And the real key was comparison of these many places. Islands to each other, islands in different climate zones, islands compared to their local continents, compared to their faraway continents. Two islands that have exactly the same kind of physical conditions, but one's in the Eastern Pacific and one's in the Eastern Atlantic, and they have completely different flora and fauna. You all know what do their flora and fauna look like? They look like Ecuador and Morocco. And so these geographic patterns are really key. The same thing holds for Alfred Russel Wallace. We'll come back to the comparable experiences of Wallace, but notice again in the Malay Archipelago, which is modern day Indonesia, from Singapore across Indonesia, extraordinary number of island habitats and places that he explored as well. All right, so here comes a slide with a bunch of words. My students know the words are there, take away the ones you want, but I can't help but, it's the way I think. So they shared something, the background in natural history. The background in natural history, Darwin born in 1809, Wallace born in 1823, was natural theology, creationism, everything made. But that was a great thing for biology education because it made you have wonder and awe in the natural world. In fact, it was an act of piety to study and understand things like gorgeous adaptations and functional anatomy. The wonders of the mechanisms that couldn't possibly have come to be engineered so perfectly without the creative mind behind it, God the creator. And this was also a theory of that taps into Linnaeus, who came up with the phrase of the economia naturae, the economy of nature, which was this cycle of propagation and preservation and destruction. And you know this one because you've all seen the movie. So this is archaic natural. This is the beginnings of ecology, but of course something completely off because it's about perfection and stability and harmony and nothing ever changes. And it's got a glorious hierarchy from the king down to the antelope celebrating being eaten, and ultimately for the good of man. All of it designed and put together. But something else was going on right in the early 1800s, a real move to make science move away from, well, what one of the scientists, in fact, I should mention him, he's not in the slides, William Whewell, one of Darwin's professors at Cambridge, an early philosopher and historian of science, he coined the word scientist, meaning like there are artists, and some do projections, some do drawing, some do painting, some do sculpture, but they all do art. What about the sciences? It was all divided into all these different things, but there's the scientists. It's more about the way of reasoning and coming together. And that science, they thought, should all be like Newton science, where in fact, miracle and magic, divine interpositions, as Whewell said, disappear and we replace them with laws, mechanical causes, operations, natural causes instead. And the science that was leading the way was the science of geology, exploring deep time. And here's a map from Cuvier, the great anatomist, his map of the Paris Basin. And you can see there are layers of fossils and then a layer of terrestrial, then a layer of estuarine above that. They were getting the idea of this Earth changing dramatically in different ecosystems over deep, deep time they'd never imagined before. And they were looking for natural laws to explain this. The way Cuvier explained it was that God wiped it all out and built it all anew. So there are no relations between these patterns. So that's the background that both of these young naturalists shared, even though they're 14 years apart. So let's start with Darwin because he's older, and we'll come back to Wallace. He had an education in scientific thinking. He was really driven by his fascination with nature. He'd grown up being a naturalist on the countryside, a wealthy family. His father was a doctor. He was sent off to Edinburgh, the best medical school in Britain, to be a doctor, like his father and grandfather before him. And he really didn't like it all. He hated the surgery on a small child, pre-anesthesia days. He didn't like some of the boring lectures, but he really kind of liked getting out in nature. He joined a natural history society that a professor ran. So he was kind of like hanging out with Mike and being a surge. They went out exploring, trying to discover things. He discovered the larvae of the bryozoan Flustra foliacea, which is here. He played around in all the tide pools around Edinburgh, fascinated by cuttlefish, the way they change shapes, and he would do all sorts of little personal experiments in their behavior, noticing the things they did. And he did not want to be a doctor. So he came and told his dad, I'm not going to be a doctor. I'm too sensitive. I don't want to do it. Well, his father's afraid he'd be just useless, all the wealth in the family, and he'd just become a, gambling, drinking, what's the polite phrase for whoring? I can't remember. So he would be like the upper class. And this was this middle professional class. It was supposed to be solid, sober citizens and contributing to society and, good, strong people. They were liberal politically. They were abolitionists. they well-educated people. So off he goes to Cambridge. And what are you going to do if you're going to be respectable and you're not going to be a doctor and lawyers out of it because there's no family tradition, and you're not going to be a businessman because that's the in-laws, the Wedgwood family of pottery and ceramics fame. So what's left? The military. Well, he's too squeamish to be a doctor. This is just after the Napoleonic Wars, so that's not going to work. What's left? Priest. So he's going to be a clergyman in the Church of England. So he goes to Cambridge to become a clergyman, and there he starts finding all the naturalists who run like natural history clubs, like the botanist John Henslow, and they would go out collecting and then gather at Henslow's house and prepare their specimens, have a nice meal cooked by Mrs. Henslow, and just this wonderful time. So he was sort of a goof-off student in many ways, always spending his dad's money. He graduated at the top of the people who don't get honors. So he's a B student, right? So here he is. I guess he's B student, 3.0 or something. But he read Humboldt, Alexander von Humboldt, had traveled in South America and wrote this brilliant, evocative, beautifully written descriptions of all kinds of wonderful stuff traveling along the chain of the Cordillera and in Venezuela and Ecuador, called Peru at the time, and coming through Cuba, coming up to have dinner with Thomas Jefferson, and then writing this glorious book of a narrative of travels. Some of the first experiments with electric fish in South America, by the way, by Humboldt. Darwin was fascinated by this, but particularly he caught on to what Humboldt called the chain of connection by which all natural forces are linked together, made mutually dependent upon each other. So he got this ecological mindset added to his skills of, knowing what bird it is by the plumage, the call, and all that. And he was kind of rare. That slide on the lower right is one of his herbarium sheets. It's still at Cambridge, where Darwin collected this plant. And you notice there's 3 plants there, 3 forms. It's one species. They grow in 3 different habitats and show this morphological variation. So the one thing little different about Darwin is he was in that first wave of people just beginning to pay attention to variation amongst individuals because everybody else is doing taxonomy of the species. Right? And the variation was something they ignored. It was flaws in the collection, or it wasn't the perfect specimen. So a little bit of different. We will see that Wallace got inspired about that variation by reading Darwin's Voyage of the Beagle. So there's sort of a pass on here. So what did he do on board the Beagle? Well, he was supposed to collect. He was a gentleman paying his own way. He was not a member of the Navy. The captain wanted a companion for a little sanity and someone outside of the chain of command with the rigor of an expedition into really difficult waters of Tierra del Fuego and south of there, which our captains can tell you probably some hoary stories of how rough the seas and how dangerous it is there. And so he's a collector. He gets a specimen for himself, and one will belong to the British government through the Navy. And they put out nets overboard and small dredges. He was the first to use a plankton toe on a scientific expedition, and there's the toe, and he made some modifications to it. So here's this guy, 22, just out of college, never done anything, throwing a ship. Hi, go to South America, do some science, right? Less prepared than you all are. So it's really kind of extraordinary. He did his taxonomic classifying. He was smart. When he got one he knew, because he'd studied that group before, he would classify it. Or if he didn't, he'd look it up in one of the books that doesn't show here, but the cabin where he was the chart table as well for making the chart. And there were 800 and something books aboard of all the books they could find about South America, geology, flora, fauna, customs of people, politics, everything. He did a lot of noting of ecology, like as they transited the ocean, he was noticing ocean temperatures and the change in the plankton they were getting, all kinds of things. And he started noticing climates and different kinds of biomes. And he mapped the geology because the ship was doing that. And his captain, Fitzroy, was a really good geologist. And Darwin had with him a copy that Fitzroy had bought him of the latest book in geology, The Radical Theories of Charles Lyell, who was arguing for slow changes with uniform causes. That if you can measure erosion now, you can make an extrapolation of time and figure out how long it took for that valley to be cut or that mountain to slide down. All right, so how did Darwin think about his own work? Basically, it's that he had a lot of energy here and he concentrated to whatever he was doing, and he sort of brought it to bear. And this was the training, sort of constantly trying to connect things. And then later, his son was in college. He wrote a letter and said, "I've been trying to think about what made me a famous, discoverer. And really, lots of people were much smarter than me in college and everywhere else, but they never ever originate anything. And it's because he was always asking questions, right? The art consists of searching for causes and meaning in everything. But here's this really curious young man who's relatively untrained. So off they go. I'll try to go really pretty quickly through the voyage so that we get there. All right, so the first thing they do is they land on an island. They couldn't land in the islands north of there because the cholera outbreak had just started in 1831 in England. So the ship was quarantined, wasn't allowed to land. So his first landfall is on a volcanic old island where there's already a sandy beach of shells, and all the flora is of Africa. I mean, fascinating stuff to him that he saw, and that the book he had in hand could be applied right there. And he starts making like measurements and realizes in some ways that he can be a geologist. Then they make a stop at St. Paul's Rocks, in the middle of the Atlantic here, this unique little place. And that looks like he landed here. And he noticed there was only a couple species of birds. In fact, the full list of fauna of the island is, there's a fly, there's a moth that eats feathers, feather detritus, there's a tick. I think that's it for animals, other than a noddy and a tern, a kind of tern and a booby. And, that's sort of it. But, and a crab. And he noticed that the birds were so tame, the same species of birds he'd seen elsewhere. He said, I could have taken as many as I wanted with my geological hammer. Just walked up, donk. So, I mean, really weird kind of an island pattern. Then he lands in Brazil, a bit of the forest there. And they started exploring along the coastlines. So the ship goes back and forth. Darwin goes ashore and lives with a British merchant, rents a space in his house for several months, so really exploring the land. Then the ship keeps surveying down south, and Darwin goes ashore and does fossil collecting and traveling inside the edges of Patagonia. In fact, discovering this extraordinary, big 14-foot long ground sloth, which is named after him by the museum back in London. They were sending their specimens back by other passing ships all the time. And the fossils are really important. So the first thing about Darwin's thinking is he's a good naturalist and he's becoming a good geologist, and part of his geology is fossils, because knowing the fossils tells you what the ancient landscape must have been like. And he noticed in particular that there are these giant forms of things that have a smaller representative now, or places that had once been a forest with giant petrified trees is now dry plains of Patagonia. And he saw that this is a bit in the Voyage of the Beagle book that he published a few years later. The discovery was he saw there must be some law where the form is replaced by something similar. So he's getting this idea of the sequence of fossils coming up in time. Is telling them that there is a relationship. They're not all independent. It's not just wiped out and created. That maybe there's some connection. But of course, evolution's a crazy idea from the time. But he's just getting these hints and bits and pieces. He's also, by going all the way down South America, he's seeing latitudinal and geographical climbs in ecology as well, like where rivers make a barrier between species, where the form shifts. He's beginning to get these inklings that the distribution in space is like the distribution in time. So, because he's constantly kind of thinking. So there they are, exploring all over inland, more fossils. He makes some comparisons in the Falklands, and there he discovers that the Falkland fox, a unique species, is different on every island in this small little archipelago. All right, interesting little thought. Then they're onto the Patagonian coastline, where clearly it was ancient marine, which has either been lifted up out of the sea or the seas have subsided. They don't know yet about the ice ages. That's about 10 years later. So they don't know about sea level change, but they can see the evidence that it was once, one or the other must have happened. And then on an inland expedition with the captain up the river valley and this great, huge canyon area of the Santa Cruz in Patagonia, they measured all kinds of erosion, and he got pretty well convinced that that big valley there had once been an inland sea, which split all of the southern part of South America off as an island and series of archipelagos. So he's measuring and seeing these, very large changes over time. Well, if you're an ecologist and you start thinking about all the large changes to go from like forest to dry badlands, you start thinking about, yeah, but everything's supposed to be, remember, perfectly adapted in place to be in their place in nature, which means the species must have to shift along with the landscape. And Lyell's geology says all this is gradual and slow. So shouldn't there be a mechanism to let the animals and plants gradually and slowly become evolutionary? And here's where my colleagues and I split. I was trained as an ecologist. So for me, Darwin the ecologist discovered evolution through ecological patterns. And my friends who are paleontology historians say, Darwin saw these fossils. He's an evolutionist already. And he left so little notes about what he was thinking in his field notes because he was making field observations, not writing up theory at the time. So we really don't quite know. And you can't trust his memories when he writes an autobiography at age 70. Right. So he has seen some remarkable stuff. Continuing on to islands, they spend time in Tierra Fuego. They come around to the Chiloé, a gorgeous place in Chile if you ever get a chance. Archipelago with thick, wet forests. Just a wonderful habitat. And by now he's seeing quite different islands, very different places, all next to continents and sharing some features of their local continental source. And then he goes to the Galapagos. So it's not like Darwin got on a ship, went to the Galapagos and discovered evolution. When they get there, this is the chart Fitzroy made. He's found it was this whole little world within itself, a satellite attached to America, 600 miles away, where he got a few colonists, then got this general character, and maybe we're brought to that, what his professors had called the mystery of mysteries. Where do new species come from when the world changes? These are hints he put out. This is in 1845 when he published his voyage book. And so he's hinting at evolution because he's been a committed evolutionist, but he's not publishing on the theory because it's too radical and crazy for a young scientist to put out there yet. Just to show you, the Galapagos Islands themselves are remarkably diverse, and he discovers a bunch of the same things, variants of the birds across the islands, the tortoises, can be identified by island and small variants. He's getting really puzzled, and he was really fascinated by one bird. Yeah, you all know the Galapagos mockingbird. Yeah, it's the mockingbirds that caught him. He always wanted to hear one because there are no mockers in England. And these birds that can mimic other birds, he thought they were so cool. So he collected them real carefully, kept good notes and all this. He kept great notes on the plants because he couldn't identify most of them. It took him 10 years to convince his friend at the Kew Gardens to maybe take on the task of identifying Darwin's specimens. He didn't identify everything for the voyage. When he came home, it was parceled out to all the best experts in England. And he was the editor, 27 years old, editing the major figures in the field for the collaborative work. There was some trust in his experience, I guess. And as you can see, it's all about this, they're near Africa, they look African, and it's not that they're in the same ecology, the same physical conditions. That won't explain what they are, what they're, what groups they're in, they're classifying. It's by what's nearby and what they perhaps change into related. Now he finally sails. They have to do the transit of the Pacific, and this is the longest single time at sea. But by this time, he has an idea in geology. He knows there's a mystery of coral reefs. And coral reefs are big, amazing structures. They're of incredible importance for ships to not run into them. And they make all, atolls and fringing reefs and barrier islands and barrier reefs. They're really fascinating. And the idea had been that God put into the coral animals the innate desire to build up from the ocean floor and make a ring and thus to shelter the inhabitants. Well, a Lyellian geologist would say, well, there's undersea mountains and things grow on them. And just before Darwin's expedition, a French expedition, the sailing of the ship Uranie, they had discovered that coral will only grow down to 25 or 30 feet. So they're not growing up from the sea depths, they're growing on the fringe. And Darwin says, before we left South America, I already had a theory of how coral reefs works. And all I had to do was measure. Well, the ship was a surveying ship. They took soundings and geological profiles, and he figured out a theory of how they grow around the fringes. And as the sea level goes up and down, or if it's on a volcano, it's around. If the volcano blows up and it's a crater, you get an atoll. He wrote the major theory of coral reef formation. And it's his first book, his first great scientific success. It made him famous, as expected, as a geologist. But it also taught him that, the biological and the geological are interplaying, especially on these islands where they're new soil has to be invaded by new animals. Who gets there? The random stray vagrant, migrant animal. And he's really starting to think about the two going together. So what about those Galapagos finches? When he gets back home after 5 years, he was rather sneaky, something you ought to do. He got home to London. It took him, he found a coach to hire. He'd take him to their home in Western England. And when he got home, midnight, 2 a.m, and he snuck into the house. He's been gone 5 years, and he just comes down to breakfast. Hi, Dad. So nice thing to do, and you've been away a while, right? So he settles in London, living with his brother, and he starts going through his notes, shepherding all these publications of the other scientists, getting stuff named for him, joining the scientific societies, networking with all the experts you meet as a young scientist. And he does this. One of those people, John Gould, tells him, those birds you label as all those different things, warblers and woodpeckers and sparrows and stuff. You're wrong. They're all finches. They're all like in the same group by their morphology. And Darwin realizes this evolution idea is really true. They really are branching. And the image is not a tree, it's a coral, right? A coral that branches, but the idea of branching out from the root and making the clade. So complicated slide, because I have to move along here. But, on top of Darwin's own, theoretical clade of life from the origin of the species, I put, there's the geological side where he realizes the gradual geological change, the sequence of fossils where once one goes extinct, there's never anything like it again. The ones here look like derivations somehow of the ones below. It leads you to the tree of life, and island species were really important. And on the ecological side, he thought about all the theories there were and about how variation and heredity work by talking to animal breeders. And then he found patterns of heredity. He knew there was local adaptation. He read Malthus about population rise and growth rates and population control. And he realized here was the key. Malthus had it wrong. Malthus thought God made all the destruction, epidemics, famines, all these things to keep us balanced. And Darwin realized, no, it makes all that within species competition, which can drive change. So the model is the coral reef theory. Little animals do their thing, and thousands of years later, you've got a reef. They didn't intend to build it. It just happens as a consequence of their actions. In natural selection, everything competes. The ones that win carry the genetic variant. And what comes out in the pattern of life is just the consequence of a dynamic action. It's a really radical thought. It's one of the most radical thoughts in human history. And someone else did it too, just a little bit later. So what about him? He was inspired by evolution in the popular imagination. Wallace really liked theory. He's a self-educated guy going to public lectures in science and reading all the books. And he fell in love with this anonymous book, which pushed an evolution theory with some sort of branching off tree on a linear scale leading up to us, the perfection. So not quite a modern evolutionary theory. The scientists all thought it was junk. Wallace kind of loved it. And he had read Darwin. And he was fascinated by the hints in Darwin's voyage about change and local adaptation and all this sort of stuff, that maybe we might be getting there. And so he had this intent to go explore that. And how was he going to do that? He's a middle-class guy, sort of bouncing between jobs. He decided with his colleague, Henry Walter Bates, they would go to the Amazon and they would collect specimens, ship them back to England to Samuel Stevens, who would sell them at auction to rich collectors who would send back money or supplies or whatever. So, you collect a fancy butterfly and send it, and it brings you back, a couple of shillings, a tenth of a pound. Just making your living like this. Bates did it for about 8 years and discovered something like 7,500 new species of butterfly of insects. Wallace did it for a few years. They split up. He did mostly the Rio Negro, not the Amazon, and came home to make his fame as a scientist with all these collections of a place hardly any English or American naturalists had been. And his ship burned. His specimens all went down the Caribbean. Heroic rescue at sea after they floated around for a while. He came home kind of celebrated, but with nothing. So he went to Singapore, scraped up some money. He went there, and in Singapore, he first sort of acclimated and figured out where he'd go. He had a young assistant, his servant, and sort of collecting. And I'll tell you, this is how my day goes, he says. I get up at 5:30, I bath and coffee. Sit down and arrange and put away my insects from the day before, put them in a safe place to dry. Charles mends our insect nets, fills our pin cushions, and gets ready for the day. Breakfast at 8, out to the jungle at 9. We walk a quarter mile up the steep hill to reach it, arrive dripping with perspiration. Then we wander about the delightful shade along paths made by the woodcutters until 2 or 3 in the afternoon. We come back with 50 or 60 beetles, some very rare and beautiful, and then we pin them and set them out. Next day, the same. So here he is collecting and then sending these things home and trying to sell them all. This is the route that he took, though, over these 8 years, all through the Indonesian, modern day Indonesian, what they called the Malay Archipelago at the time. And you can see, once again, we have all this sort of sea route, but he is doing this, complete exploration on land, and a little different in a way. He's basically living on land and then transits to another island. And my colleague, a co-author of mine, Randy Jackson, suggested that maybe Wallace thought differently because he spent way more time. Darwin was at a place, then they had to leave. He did stay a few months in Rio and a few months in Chiloé and a few months here and there, but for the most part, they were moving all the time. And Wallace really was embedded in the local landscape and really seeing it and studying it and collecting a lot more variants, a lot more specimens. So you might think so that's him in the straw hat there, negotiating. Because what he did, Indonesia is one of the most densely populated human places on Earth. So he was in villages and talking to people saying, hey, kids, I need the birds that have that color. And they'd be out collecting for him. My colleague, John Van Wy at University in Singapore, has just gone through Wallace's correspondence trying to figure out something we've all wondered. And he's calculated that Wallace may have hired up to 1,000 people in his 8 years as, paying them as collectors and getting local knowledge, asking them stuff. One in particular was a person who was with him several years, a man we know as Ali, who was his cook, his local guide, and a companion in all these travels. And these are some of the collections from the British Museum. Wallace was, of course, collecting for these fancy rich guys. So he's looking for the exotics, the big dramatics, fascinated by the birds of paradise in particular. That one on the right is the glorious standard wing bird of paradise, Semioptera wallacei. So he's getting well known for the specimens and the exotics. So even though he may have been looking more closely at a place, he also was drawn a little bit commercially, like to look for the really extraordinary and ignore like the ordinary stuff. Like as if you only worked on guillemots and never looked at barnacles. Well, that'd be okay for the guillemots. And someone would love to know all this stuff. So anyway, it's an intriguing sort of comparison. But to remind ourselves, he worked a huge number of these islands. And what was he doing there as he thought through? He good anthropological notes, good ecological notes. Oh, by the way, the note we have when he collected that bird of paradise, Charles was out. Ali was out. And he came back in at noontime when you start taking siesta when it rains in Indonesia. And he came back in and he had some birds hanging from his belt. And he said, sir, I've got one I think you might be interested in, and held this thing up. And Wallace knew it was one no one had ever seen before. And he also knew from the geographic range of all of them that it was well away from where it ought to be. So it was really exciting and exotic. And he writes, it's not where it's supposed to be. It's brand new to science. I can get at least 25 pounds for this one. That's a quarter of the income of a workman annual, right? 100 pounds a year would be a workman's wage. He thought he could maybe get 25 pounds. So what's that? That's $10,000 for a specimen, right? So a little different kind of experience, but what was he thinking about? He's collecting abundant variation. He's noticing the varieties distributed all over. He notices boundaries and geographical patterns of shift across the landscape. There seems to be uniform geological causes that we ought to apply because he had read his Lyell. And he thought that these recently formed islands near continents should be more like the continents and the further away they were. And he did two extraordinary, and the sequence of fossils seemed to imply change in place, evolution. He already thought that was a good idea. He just didn't know how it could work, just like Darwin at first didn't know how it could work. But he did two things. He published very bold papers. One was in 1855, and he published this law, which said every species comes into existence coincident in time and space with the pre-existing closely allied species, evolution in place. And he said, I'm outliling Lyell with his gradual causes. So really bold move. He sent the paper to everybody. Darwin read it and said, yeah, this is really, if you want to read a piece that says, why the geological evidence implies evolution, it's a brilliant piece of logic and clearly written out. And then the orange red is Wallace's line. where he noticed that as you get further from Asia, the species, that they start off being all the Asian species and they get reduced because they can't get that further and further out islands. And then you get closer and closer to New Guinea, it's more and more Australian stuff that's come westward. And, the line is this sort of break between these two major things, which before would have been centers of creation where God made them different. And he showed it was all patterning and changing place. Like as you go further out, the smaller and smaller islands it's not a very map, is it? On the further and further islands out from like right above where it says islands, you're at the end of Java, and you go out Bali, Lombok, Sumbawa, Flores, you go out, you get more smaller and smaller islands with volcanic cones, they're windswept. What happens to all the insects? You get more and more wingless forms. Because if you're an insect on a windblown island, the worst thing to do is fly. Because you get blown to sea. The most likely place you are to land if you fly is in the water, right? So you get this form. And this is the kind of stuff he was noticing. And you'll notice this is a familiar slide. I could have said Darwin's field and theoretical work at the top, and it would have been the same thing. Unbelievably parallel thinking, completely independent, except that Wallace had read his Darwin, so a little different. But he also had another moment. He realized that he needed somehow. So he's lying in his hammock in a fever on a far remote island in the eastern end of the archipelago, a place called Ternate. He's on one of the other islands. He's not quite there. That's what it looked like at the time. And his younger brother had come out to join him in the Rio Negro, his younger brother Herbert, and within 6 months he had died of yellow fever. Wallace found out years later because he was off somewhere else. I mean, this is rough. These guys, heroically living like this hand to mouth for 8 years, with Englishmen in tropical climates, they're not, their immune systems, just, rigorous, tough people. And he's ill. He's got probably a malarial cycle of fever. And lying there, he thinks, that guy Malthus wrote this book of population where most, things die off and, kind of looking a little rough for me right now. But wait a minute, if there's a lot of variation and then some of them die off and the ones that fit better kind of survive, why, this might be the key to evolution. And he writes that famous paper, a draft paper, and sends it to Darwin saying, if you see any merit in this, you can let me know, should this be published? And Darwin sees merit. He says, it's as if he had my notes in front of him. Exactly the same parallels. We scholars who nerd and nitpick at everything, you can now read abundant articles from us about where the differences are. And theoretically, for evolutionary theory, they are interesting. Wallace is more of a group selectionist. Darwin's more of an individual. There are differences, but the overall pattern is extraordinary. And the fact that they had all this piled up and couldn't find the key until they finally realized, that it was this population pressure and the death rate. And you really see it on islands, don't you? You're living amongst the animals. They're abundant because they're like seabird colonies and they're just dying all the time around you. And it really hits you. And this is a piece I'll give you for free because it's supposed to be the paper that's going to come soon. But we haven't really noticed like the dramatic difference of sort of life history experience of being in some of these places. We tend to think, all the patterns I saw are all the same. But I want to make a claim the islands are incredibly important. So we have this set of parallel insights. They're younger, they're settled by migrants, they come from the nearest older land. That will give you the origin species that will then diversify. They have all these unique habitats, biological separation, and different ecological pressures. So they'll have locally adapted form and radiate, and you'll get this diversification. And it removes the need for the specially created and for the intent and all that. And you have naturally the biogeographic natural historical patterns. In other words, you get evolution by natural selection. And so what I want to point out to you as we finish here is that they were young and relatively inexperienced. They did it by incredibly rigorous observing, keeping really careful notes of everything, constantly asking questions, open to new ideas by reading the latest. Darwin was much more cautious theorist and really wanted to see rigorous. Wallace seems to liked every theory he ran across, but he tested them. Right? I mean, they might have been different in their way they approached things, one more adventurous, one more cautious, but both of them realized they had to find a cause, an explanation that rather unified everything and extended it. It's interesting that Wallace is one of the ones who really picked up on animal coloration, which his friend Bates read Origin of Species and said, it's like the laboratory of nature where I am, in the Amazon. So they were all thinking the same thing, and everyone, they all needed a key. And then the last piece is, because Faith has been making me think about this with students and how they learn, is you've also heard a story of how two young men got that what we call self-efficacy. They both discovered they could be scientists, right? By making a discovery. Darwin saw something no one had ever seen, as an undergraduate in the tide pool. Wallace saw species and figured them out that no one knew anything about. They found out they could do that scientific work, which I think is also a part we often forget about, is that you have to, have some sort of mindset of being able to change ideas amidst your rigor and find out you really can make discoveries. That's what I've got for you. I want to give thanks in an unusual way, because I have graduate students and we work on some of these things together. But my major acknowledgement is to the heroic librarians and archivists who have saved all this material for us. And in the internet age, you have the phenomenal thing. I used to go to Cambridge and put on the little white gloves and touch the pieces of paper. They're all online. The Wallace's correspondence is getting there. Every letter we have to or from Darwin is on an online archive. You can read them all, 16,000 of them. All of his publications are online. All this amazing stuff, one from Cambridge University, from this British government funded the complete works online. There's that Alfred Russel Wallace correspondence project now, so I can read dead people's mail. And we have also 3 or 4. Charles Smith started it years ago at Kentucky, Western Kentucky, but now there's a marvelous British Wallace Online site as well, as we're trying to raise the profile. That it's not all just Darwin, but it's another person as well. So I'd be happy to take questions, because there's lots about these guys, which is fascinating. Thank you.
Thank you, Will, very much for that fun talk. It's great.
47 instead of 41.
Spot on. Amazing. All right, so do we have time for questions, audience?
A great talk. Thank you. I'm curious to know if you think that islands are more prone to rapid evolution as compared to mainlands based on their findings and everything, as well as, here, many studies since.
Yeah, and I think they got kind of lucky by both, going to archipelagos or going across the whole world. Because the kinds of ecological pressures on the islands, they are more intense, right? And you get these concentrated populations, especially if you think seabirds, they're coming here because they're remote from predators, like you'd notice in St. Paul's Rocks and places, which means you get huge concentrations. So that, the death rate's really high here. So yeah, I think so. I think islands are a good example. Losa's work in the Caribbean with the Atolls, the rather rapid morphological change under serious selection pressures in a small population. And the other thing they do is, of course, they're migrants and isolated. You get genetic drift, you get bottleneck effect and stuff with that small population being diverged and separated. The question you had the other day in class about, well, when geographically apart are they active in species? That's going to happen with islands. So I think seeing these places was kind of the perfect place to discover evolution. You weren't going to do it sitting in your garden in England, seeing, only one kind of system. It's the comparison of lots of ecosystems, especially in intensive places. But yeah, nice thought.
Thank you for your talk again. I have a question. In your review of looking at like Darwin and Wallace's like works and papers and journals, did you notice any I guess more complex ideas of evolution that they didn't know how to coin yet, like such as like adaptive radiation or like hybrid zones going on in the area, especially with like the finches on the island, how they all like separated into different species eventually and got their own niches.
Yeah, the adaptive radiation, Darwin keyed in on right away, that he was getting this insight, like, well, the locals can tell you, the islands are different already. The birds are different here. The tortoises were different. The finches were sorted out. There's some of the species, different islands. it was the hybridization which really bugged it. And worrying about, well, if you're going to split, like, well, how much separation, is it over time or is it in different places? Ended up finally coming down to really needed barriers. He became a kind of geographical isolation person. He couldn't really quite see how you would get what we used to call sympatric speciation. The idea that you could just evolve in real close spaces together, because he kept seeing that their heredity theory at the time was a blending theory. So this is 50 years pre, segregating factors in helium genetics. So if everything was blending, it was kind of like knowing what we know now about gene flow. It doesn't take very much to keep everything in a pretty unified genome, right? So for him, the hybridizing that could happen would seem like it would be really hard. So he thought evolution would be really slow. Boy, I would love to time travel him and plop him down on the Galapagos and let him meet Peter and Rosemary Grant, who have tracked speciation within 50 years. And they've seen it start to speciate and then collapse back as the drought cycles change with the ground finches. So he was most puzzled by that hybridizing. So that's an area he didn't go. I will add one cool thing though. He was a cautious guy. He wrote a great note in his autobiography that he had one habit of mind, which is really useful, that whenever he came across a fact that was contrary to his theory, he made special note of it, for I found I was most likely to forget. So he constantly challenged himself with the contrary instead of looking for confirmation, right? And so the middle chapter of The Origin of Species is called Difficulties on the Theory. And in my dissertation work, I showed that there isn't a single example until you get to molecular genetics of the last 20 years. And until then, there's not a single problem for evolution that he hadn't thought of and tried to answer in the very first book, which is just, that care of 20 years of, I'm going to challenge my own theory. Yeah.
Thank you.
You had Kate in the back. Yeah.
So I'm sure that you've heard of this book, but there's a book called The Feather Thief, and it's about it's about a violin player who went and stole, was it 200 or 300
Yeah.
per feather
Oh.
time. What kind of impacts have there been any impacts on your own research regarding the investment or anything like that? Or
Yeah.
And who their work impacted by that?
Yeah. So the book, The Feather Thief, there's this marvelous young man. He's self-educated. I guess one would say he's on a spectrum somewhere. And he has unbelievable skills in these really narrow ranges. He's a genius at something. He's a self-taught musician in multiple instruments, sort of computer stuff. And he became a master trout fly tying person. And if you know about tying flies, you use these little bits of color feather of some of the most exotic birds. And they're really expensive stuff. That's one of the reasons he could sell some of his, even Wallace could sell some of his fancy feathers, because you need like those 5, breast feathers from the, South American coronet, the green coronet or something. So this young man became this master, competitions and everything. And he really just had this passion to acquire these feathers. So he flew to, he's a New York person. He flew to London with 2 empty suitcases, and he got a train up to Tring, which is the place where the Rothschilds had an estate, which they ended up donating to the British Museum of Natural History, now called the Natural History. I'm sorry, I used my 19th century name, the Natural History Museum. It's a archive museum site of collections, but it's all, got grounds as botanical garden, all kinds of things. And he went up there and he walked from the train station with his 2 empty suitcases to the building. He broke a window and he climbed in and he cleaned out the cabinets of all the birds of paradise. All those specimens were gone. And not just the birds of paradise, but Wallace's stuff in particular, because they're so desired, and a bunch of other different groups of birds that have really colorful feathers that are needed. And he's, then he was the guy amazing at the conventions and competitions who always had a few of those that he can sell. Like, where does he get them? They're so rare. And he had a couple of suitcases full of them stolen, and he was finally busted. And when they got the specimens back, the tags had all been removed to pluck feathers. So they're useless. Even getting them back, they're just birds stuck with arsenic now. I mean, they're useless as scientific information because there's no detail on it. Now, sometimes you can reassemble it because we have field notes and we have letters. We know exactly the island where he was when Ali shot, Semioptera wallacei. So you can, and in fact, there's a cool side bit here that Darwin, when the guy told him that the finches, they were all Geospiza, they weren't all these different orders of birds. He had to go to the ship's log for the captain to figure out where they were because he'd taken such terrible field notes. He had to reconstruct where he got each finch. Right. So those the continuity of an archival thing, it's like in archaeology. You've really got to have that, or you really don't know what you have. This is where we've been using the field notes and stuff. It's a cool book, by the way. It's a detective story of figuring it out. Guy never went to prison or anything. So, like the feather thief.
Yeah. So obviously Darwin and Wallace were, from a time very long ago where radical exploration and discoveries were, I guess more possible than an era like today. So in an information, era that we're in presently, what advice would you give for, new students to kind of pursue meaning in the natural sciences for discovery?
Yeah, I mean, well, one thing is I think that great insight he had as a young man, that everything needs to be connected. I mean, most of the research labs one would go to become professional scientists are going to have teams of scientists where, Nick's got computer coding people who help him, and then someone else has molecular geneticists helping them, or you've got a biochemist because you do, like my early work, plant insect interactions. You got to know the biochemistry, or you've got to, all these different kinds of disciplines. So that's one way. I think we're still making the connections and the multiple causation that goes on at once because we have the computing power to run models and we have the equipment to gather that stuff. So that's one thing about it. But also just remember, let me see, some of my colleagues, maybe the citizen science kind of enterprises, right? So there was one run out of NC State and it was to collect ants, because they're the most abundant insect around all kinds of our human habitations, and we just don't know a whole bunch of them. And so the deal was to have kids put an Oreo cookie in a plastic sandwich bag and put it out somewhere, and then come back later, and if there's ants in it, seal it up and send it in. And a kid in New York City discovered a new species of ant in New York City. I've got a friend at home who is a specialist on fireflies, and he told me that in May, they discovered a new species of ghost firefly in the county just south of me. I mean, there is stuff out there, and it's not just go to the tropics where we're, thinking we don't know it yet. I mean, it's actually all around us. And in many ways, one of the great ones there would be, many of the invertebrates, especially bacterial, right? The bacterial world we still know so little about, especially for oceanic water.
I love that thought, Will.
So we all know that Darwin has many famous, widely accepted theories that we still learn about and build upon today. But did he have any outrageous theories that we don't know about or talk about really?
Yeah, he made a couple of geological, boneheaded arguments because he didn't know about glaciation, and he really read the landscape wrong and the causes. He always called those an embarrassment. Let me see, what else did he have that was really dumb? Part of it that we can constantly think about correcting is it's really complex about his thoughts about human variation. He was an ardent proponent that humans are all one species, right? They're way too similar that what people were calling race was minor things. He'd been taught his taxidermy by one of the smartest people he knew, an ex-slave in Edinburgh. He was different from, he's from an abolitionist family. He thought differently about humans. But on the other hand, he also, couldn't quite figure out which was cultural. Just imagine, you come from settled West England, you've gone to school in Cambridge, you've had money, You know, you have all the sort of comforts of life, and you go to the ship and you meet Fuegians who have Stone Age technology, you know, and are mostly foragers, tiny amount of agriculture, and just, you know, completely different shock of the new people. He saw it as all human within the human variation, but he also thought, you know, and it's a prediction. It's not a goal. So you have to be careful when you read people's words, right? But he said, basically, these people don't have a chance. They're going to get run over by modern society. They will be extinct. You know, it's like all the languages in the world. They're going to be gone. The dominant culture just spreads. Stuff disappears. And he saw it as natural, but you might think, well, that's really terrible. You know, he's calling for their extinction. No, he's just recognizing that the dynamics are that way. His thoughts about gender difference are also interesting. He's a person of his era, and he thought there might be mental differences, you know, things like mathematical ability, which he had none of, right? He had a quite wonderful relationship in his family, you know, teaching his kids, living with them, you know, much closer. They didn't get put off in the nursery or off to the governess, off to boarding school. Very nice relationship with his wife, who promoted his work. You've heard the legends that, you know, he was worried about her religion. That's why he didn't publish. She hired the copy editor and the transcriber for his book and pushed him to publish. That's what you find out when you read the letters and the diaries, right? You get past the myths. But, you know, his ideas sort of flux. Sometimes they look quite like, oh, you know, I can go with that. But, you know, and then sometimes you're just shocked by that 19th century kind of quality of it. But yeah, totally dumb ideas in evolution. No, really more like misled by what they didn't know, mostly on genetics. Yeah, good question though. Make the speaker think a little.
Well, Will, thank you very much for providing us with that excellent talk. I appreciate it very much. That's all the time we've got for tonight. For those of you online, please join us next week. Alia Caldwell will be speaking. Alia is actually a former member of the undergraduate research group, who's now a PhD student in the biology department at UNH. So we tune in next week. I'm going to get students on that classes. But thank you very much, Will, for giving us the time. Excellent talk. Good night, everybody.
Good night.